So this is the question that is over here. What we need to do, we have to find, we have to check that the circle and triangle, sorry, rectangles are overlapping with each other or not. Okay. So we are provided with a circle which is represented by radius. It's x center, it's y center, okay, and an axis aligned rectangle represented as x1, y1, x2, y2, where x1 and y1 are the coordinates of the bottom left corner, which means that x1 and y1 are the coordinates of this corner, and x2 and y2 are the coordinates of the top right corner. Okay, so x2 and y2 are the coordinates of this particular point. Now we have to return true if circle and triangle are overlapping with each other. Okay, if they do not if they do not overlap, then we will return false. Okay, and in other words, check if any point xi or yi belong to the circle and rectangle at the same time. For example, in this particular case, this particular point, this is a 1 comma 0, which belongs to both circle and rectangle at the same time. Okay, so in that particular case we need to return the true. Similarly, if this is a example 3, we will consider here this point, this particular point, and this particular point. These 3 points are belonging to both circle and the rectangle at the same time, so we can say we just need to return true in this case. Okay, also in this case it will return false. If we try to draw this particular example, we will come to know how we have to return false over here. Okay, so how we would approach this particular problem, let us see over here. Okay, so this is the example that is given to me like this. Okay, so this particular is the center, uh, sorry, circle with the center xc and yc, and we are also provided with a radius which is represented by r. So I am not writing this for this time. Okay, so what I'm thinking of to do is just find out the nearest point from the circle to the rectangle. For example, if this is a circle, then we need to check that which particular point is the nearest to this particular rectangle. Okay, so here it is simply clear to me that this at this point, at this time, this is the nearest point between the circle center and the rectangle. Okay, so what I can say, this is the nearest point. Okay, so what is our step one? Find the nearest point. Find nearest point. Okay, from circle to the rectangle. Find nearest point from circle to rectangle. I will be represented circle with C, circle to rectangle. Okay, so this is the nearest point. Now what I can say, I just need to check if that okay, this particular point is find it out. Okay, now I just need to find out the distance. What is the distance between these 2 points? Okay, so in second step we will find the distance, and in third step what I can say, if this particular distance, if this distance is greater than what, if this distance will become greater than my radius, then I can simply say, so not greater than, equal to, simply greater than. Okay, if this become greater than, then I can say okay, this particular point is not lying inside the circle. Okay, so this circle is, these two are not overlapping with each other. How I can say this? For example, if this is a d distance that I have calculated, and this inner one is the radius, my radius, then it is simply clear to me that whenever my d will become greater, sorry, whenever my distance d will become greater than this particular radius, then I can simply say okay, this is not lying inside this circle. So means I can say these two are not overlapping with each other. But what if I would say okay, this is my circle, and this is the radius of the circle, sorry, this is the radius of the circle, let us say, and this is the nearest point. Okay, now it is simply clear to me that this particular nearest point, that is I have find it out, this particular nearest point, this is represented with a distance, and this is my radius. If my distance is less than or equal to my radius, then in that case I can say, okay, these two are overlapping with each other, and we will be able to find out the common point that we have to find out now. Okay, so in this case I can say, okay, just return true if this particular case exists over there. So how I can find out the this particular distance? Okay, so to calculate this distance, one thing that we have to check that at which side my circle is existing. For example, I can say, if in this particular example I can say my circle is existing just to the right side of this x2 and y2 point. Okay, I can also say it will exist to the left side of this. Means there are different possibilities. Okay, different possibilities, like if I draw this rectangle over here, then circle may exist over this side, circle may exist over this side, circle may exist over here, circle may exist over here. Okay, but first we what we will say, we just need to check out, is it existing on the right side, or is it existing on the left side. Okay, so this is the thing that we need to check out the first. So how we will check this thing? Okay, so to check this, what we have to find out, we have to find out what how we can check that which side. Okay, so to check this we can say, just calculate the minimum of what, minimum of my x2 and x center, the minimum of x2 and x center. Okay, if my minimum is x2, if my minimum is x2, then this simply means that circle is lying on the right side. Why it is lying on the right side? Because xc is greater, and it is, if it is a greater, then it is obvious that it will exist on the right side. Okay, and if my x center is less, for example my circle is lying over here, so in this case my x center will become lesser than x2. Okay, clear? My x center will become the lesser than x2, so in that case I can say circle is lying on the right side, sorry, left side. Okay, otherwise I can say it is lying on the right side. So this is the thing that we have to find out, at which side it is existing. Now we will be able to find out the first step, at which side my circle is existing. Okay, this thing is done. In this case it will give me x2 as the minimum one. Now what I need to find out, I need to find out the nearest point. Near, I can say I need to find out the nearest x. Okay, from here I need to find out the nearest x from the center. Okay, so what I can say like this, nearest x, which x is the nearest to this circle. Okay, so what I can say, it may be this one, it may be this one. Okay, इन दोनों में से कोई हो सकता है. So what we will say, what we have find out previously, we have find out that which at which side this particular circle is existing. Okay, it might exist on the right side, it might exist on the left side, so it will give me its existence, that at which side it is existing. Okay, so the existence is given by this particular point, that is a minimum one. Okay, so if we have calculated the minimum point, now what I can say, the nearest x will be the maximum of x1 and the nearest point, that is sorry, minimum that is calculated. So in this case this is x2, so I can simply say it will be the maximum of these 2 points. Okay, so I will be able to get the nearest x now. Similarly I will find out the nearest y. So in that case what I will be able to find out, I will be able to find out this particular as a nearest x, as like this, and from here I can say this one as a nearest y. Okay, okay. Now what I can say, I have to, but I have to find out which distance. I have to find out this thing. Why? because I need to apply the Pythagoras theorem over here to calculate this particular thing. Okay, so what I can say, how Pythagoras is applied: if this is the nearest y, sorry, okay, if this is the nearest y and this is the nearest x that I have find out over here, then I can simply say, okay, uh, this is my x center and this is my y center. So I can say just subtract y center, just do y center minus nearest y, just do y center minus nearest y. If I do this thing, it will give me what? It will be giving me just look, I will be doing nearest y subtract from y center. So if I subtract this thing, then it will give me this particular distance. What I'm doing over here, just look at, this is the complete distance, this is my y center, okay, and this is my nearest y. So I am subtracting nearest y from the y center, so it will give me this particular distance. So I will be able to get this particular distance. Similarly, I will calculate this distance as x center minus nearest x. Okay, so this will give me this particular distance. Now I will apply the Pythagoras theorem to find out this particular distance. So my distance will be calculated as equal to under root of this distance that I have calculated. I will name it as distance x and distance y. Okay, so distance x square plus distance y square. Okay, so this will give me the distance that I have calculated. After finding out the distance, we just need to apply this condition. Oh, no, not this condition. Okay, yeah. I just need to apply to this condition. Okay, if distance is greater than my radius, then I can say return false. Otherwise, I will return true. So this is the simple logic behind it. What we are doing, just look at over here again. What we are doing, we are just checking, but we are just finding out this particular distance from the nearest this distance from the center of the circle. Okay, or I can say we are just finding out the nearest point that is to the circle, or I can say what we are doing, we are finding out the nearest point in this rectangle that is nearest to the circle, or I can say we are finding out the nearest point from the center of the circle to a rectangle. Okay, so if I will be able to find out the nearest point, then I just need to apply this condition just to check it is lying inside or it is not lying inside. So if this condition will become true, I can say okay, everything is true, everything is done. Okay, now how I will be finding out the value of distance, that is this distance. So for that particular case, we just need to check if the circle is lying on the left side or it is lying on the, sorry, it is lying on the right side, it is lying on the left side. Okay, so to check that, we can say just take the minimum of, firstly just take the minimum of which, this and this, which is x2 and x center. Okay, if x2 is the minimum, then I can say circle is lying on the right side. If x center is the minimum, that I have draw this particular example over somewhere. Okay, not there. If for example, if my x center is the minimum, then I can say circle is lying on the left side of that particular point. Okay, so if after finding out this, I will be finding out the nearest x, and nearest x will be the maximum of what, maximum of that distance, sorry, maximum of that existence that we have calculated, that at which side my x is sorry, my circle is existing, at left or at right, maximum of this comma my x1 point, that is my this x1 point. Similarly for y, I will be finding out the y1 minus that kind of thing we will do, minimum maximum of y1 comma minimum of y2 and y center. After that, what we will do, we will find out the distance x, this particular distance, and distance y. Okay, I will find these two distance, and after finding out the distance, we just need to apply the Pythagoras theorem to find out the final distance. After finding out the final distance, just it is the case of only one condition. That condition is that this one, if it is greater or if it's lesser. If this is done, my question is done. That's it. So if I will say I want to write out the code for this particular case, I will say just remove this. Okay, I have written it previously, but I will write it over here again. What I said first, we have to find out the nearest x and nearest y. So I can say int nearest x is equal to what I have told. First of all, find out the minimum of what? Minimum of x2, comma, x center. Okay. After finding out the minimum, we just need to choose the maximum from where? From x1 comma minimum of this, that is find it out over here. Similarly, what I can say, I will be finding out the minimum y. Minimum y will be like this, like this. Just change x to y, and it will give me the minimum y. After finding out the minimum x and minimum y, I have to calculate the distance. Okay, so I can say int distance underscore x. What is the distance of x? Distance x will be the nearest x minus nearest x minus let me sorry okay, it will be the nearest x minus x center. From here I have taken it from here. Nearest x is this, and x center is this. So nearest x minus x center, I will do anything because it will give, after doing it will give me the in the negative. So if it is in the negative, what I will be doing, I will be just applying Pythagoras theorem, where I will be scaling up this thing, so it will give me in the positive in the end. So I can say int distance underscore y will be my nearest y minus y center. After finding this distance x and distance y, what I can say, just return uh, okay, power of distance underscore x comma 2 plus distance underscore x comma sorry plus power of distance underscore y comma 2. If this particular distance is greater, then we return false. If it is a lesser, then we return true. From what? Power of radius comma 2. Why I have taken power of radius comma 2? Because just to maintain this, because if I haven't taken power, then we have to do the square root of this. So to prevent from the square root, I can say just take the power of it as a simply. Okay, so in this I will be taking the power of it. Okay, yeah, it is working for all the test cases. If I submit it, it's working. Okay, it's working fine. So that's the solution, and yeah, it is the solution. So if I talk about the complexity, we are not running any loop or any kind of thing. Okay, just power function is used. And if I talk, I can say time complexity, it will be order of 1, constant time complexity, because we are not performing any kind of loops or other stuff. Okay,